graduate seminar. I'd like to introduce James Silvas from USGS. He'll talk to us today about disposable infrastructure. And apparently he has an intro as part of the slide, so I'll let him proceed with that.
Thank you.
Oh, and I was asked to remind you guys to swipe in for attendance at the end of the class if you haven't already.
All right, good afternoon, everyone. So I'm gonna tell you this is my first time speaking in front of students, graduate level. So please be nice. Yeah. So I was looking for some really interesting graphics. So I used the styrofoam cup for my disposable infrastructure. So the subtitle I changed up a little bit, and it's really about I wanted to focus on solving complex business problems using the disposable infrastructure, specifically infrastructure as a service. There was a day where you actually had to physically touch equipment, and now that has long been gone. Just a little bit of a intro on myself. I got a passion for solving some of the biggest problems in the world using technology. I have a lot of experience on the federal and commercial side. One of the big projects that I worked on in 2009 was recovery.gov, which is how you track $1 trillion of stimulus and do reporting, big data warehousing. It was the first project ever deployed on the cloud for the government, and it was a great success. I also have a lot of experience with some three-letter agencies that I can't talk about too much. And on the commercial world, we're doing a lot with banking and some large enterprise. I am one of the founders and executives of JEC Technology. JEC is a medium-sized, small to medium-sized business centered around taking large organizations from the federal government out of the physical data center and moving them into cloud, specifically Amazon Web Services. How many people are familiar with Amazon? Not the books, right? Amazon Web Services, there you go, you got one. All right. I'm also a co-founder and CEO of another company called GenomeNext that we started last year. GenomeNext sounds like, well, what does that have to do with cloud computing? It's genomic analysis. So it's the biggest big data problem you're going to find. In fact, they're trying to change astronomical to genomical, as it being the largest big data set that you can deal with. And so cloud computing is going to have a major impact on how you do that type of analysis. Retired U.S. Army. How many vets do I have in the room? There we go. 2. All right. So we'll talk later. Army. Yeah, 4. Oh, okay, never one. All right. So moving on. Why are we here? That's why we're here. Who has ever seen a data center closet look like that? I know I have. So I might be aging myself a little bit. Maybe not quite as bad. It's a little bit ridiculous, but that's what it used to look like. You used to walk into office buildings, and they would have a closet somewhere in the recess of the building, and that's what it looked like. And there might be 1 or 2 guys that knew how to move the wires around. No one else was allowed to touch it. If you did, it would fall apart. Additionally, people couldn't move buildings because the logistics of moving that to another building wasn't very smart. So part of the reason of cloud computing and where this all stemmed from is that. Some of the business problems of physical infrastructure is planning for the future, which we call capacity planning. So we used to have to plan 5 years ahead to determine what type of infrastructure we needed. Compute, storage, network, all these things. Most of the time, say 99% of the time, we were wrong. Usually the users outpaced us by light years. And there's also inherent problems here, which is capital investment. In order to plan for the future, you have to pay for that up front. If you get that wrong, you either spend too much, you don't spend enough, causes problems. How many people here want to start their own business when they get out of school, or maybe they already have? How many entrepreneurs do we have? We got 1, another 1. Okay, so you used to have about $1 million, $2 million to build a data center. Okay, out the gate if you were going to go into technology, and you had a plan for that because you had to buy physical assets, right? You don't have to do that anymore. With cloud computing, that kind of problem resolves itself. Time to solution. So I know in the federal space, I can give you a great example. We had, at one of these three-letter agencies, we had a plan for 2 years ahead. We bought equipment, took 8 months to get in, took us another 6 months to implement. By that time, the hardware was obsolete, and we had to go out and buy more equipment. And the time to the solution was crazy. Additionally, with hardware refresh and innovation outpacing everything, you can't buy equipment without it being obsolete within 2 to 6 months. So why put the investment in? And this is what businesses are looking at, right? They're looking at, why do I put my time and energy, money into something that might be obsolete within 6 months to a year, right? It's not a good business plan. So the other business problem with traditional data centers is disaster recovery. What's the first thing that gets cut from any commercial budget? Does anyone know? Disaster recovery is the first thing that gets cut. Why? Because who wants to buy all this infrastructure, move it somewhere else that's never going to be used, right? Unless there's a disaster. So when budgets get cut, disaster recovery is usually the first thing that gets cut. That's a problem, right? As everyone has seen, natural disasters and the way that technology is moving in terms of hacking, things like that, disaster recovery needs to be part and built into any solution that you design moving forward. People are not okay without disaster recovery anymore. So here comes AWS. How many people have deployed solutions in Amazon in this classroom? Very good, very good. So please ask questions and challenge me if I say something incorrect, which you probably will have. So Amazon regions. So a region is essentially a set of grouping of data centers, right, for a specific region, geographical region. So within a region, you have these things called availability zones, which we'll get into a little more. However, we have many regions in the U.S. In fact, we have 4. We have U.S. West, U.S. East, 2 in the West Coast, and then we have a region called GovCloud, which is specifically for the federal government to meet some ITAR requirements, federal requirements. Globally, we have 2 in Asia, or 3 in Asia, Ireland, South America, and then Australia. This is incredible. Why? If I want to deploy a solution in Amazon that's worldwide, I don't have to buy any infrastructure anymore. I don't have to put in the network. I don't have to deploy people on the ground. Right? This did not exist 10 years ago. Right? And I know that in terms of disaster recovery, if I want to fail over from east to west coast, I have all the AWS services that allow me to do that. Now, can somebody ask me, does Amazon Web Services fail? Who can answer that question? Has it ever failed? Yeah. Yeah, one yes. Who subscribes to Netflix? Yeah, lots of people, right? So there's been some Netflix issues. There's been other service outages recently. So one thing Amazon said is you got to plan to fail, right? And the reason that's important is because a lot of people move into the cloud think, oh, I'm in the cloud, I get disaster recovery, high availability, my data is always going to be there, and nothing fails. It's not true. You have to design for it. So Amazon provides you all the pieces of the puzzle. They provide you all these regions, right, around the world, and then you have business decisions that say, I'm only deploying in U.S. East in availability zone A, and they don't deploy in other places. So if there's an issue with an availability zone or a region, you're going to have an issue with your application, right? So the way that regions work and availability zones work is that I think now they have a minimum of 3 availability zones in each region. And the great thing about availability zones is they are, they're in their own floodplain, they're in their own electrical grids, and all of the Amazon services are scoped and isolated to each region. So what happens if there is a disaster in New York that affects availability zone C? Well, any application services running in that zone are probably going to experience some sort of outage. However, if you're smart, you probably deployed in C, A, and B, right? And you're using Amazon's API and auto-scaling and all of their optimization and automation services that if there is a failure, you detect it and you can spin to other availability zones and possibly regions. What that means for us, from an infrastructure perspective and an application perspective, you could design an application that had near zero downtime, right? You have to design it. You have to make sure that you have all these components in place. So this list is an old list. Amazon actually, how many people went to reInvent? Anyone go to reInvent? Yeah, one. If you didn't go to reInvent, go on to Amazon's website and you can find all the videos of reInvent. But here's the application services or AWS services that are provided. So you have your foundation services. So those are going to be your virtual private clouds. So that includes your CIDR ranges, your subnets, firewalls. It's going to include security groups. It includes all of your virtual machines, they call EC2 instances. And it's just raw infrastructure that you control and you deploy within your account. That also includes databases. How many people love creating databases and managing database servers? I know I don't. I hate maintenance plans. I hate going in and installing SQL. It's a pain. So Amazon has a service called RDS, which basically will deploy and manage and provide disaster recovery and high availability for your databases. Moving above the foundation services, you have application services. These are things that you definitely want to take advantage of. So SES, simple email service, SNS is a notification service. SQS is queue service. They have workflow services, app streaming, cloud search, you name it, they have it for your application. The reason this is important is when you're building your application, you don't have to worry about now, how am I going to build a queue service and what is the infrastructure that's going to support that for your application. You can actually now utilize Amazon services. And I'll go through some use cases of these services and how they benefit you. Deployment management. So how many people have heard DevOps recently? Anyone? Lots of people, right? That's the new key word. So Amazon has a full API that's addressable to the over the internet. Any action that you can perform in the Amazon account, you can perform through coding and scripting. Everything can be automated. That's the infrastructure side. But what about the application side? So Amazon provides full services for OpsWorks, which is Chef, essentially. It's a managed service. How many people know Chef? I hope a lot of people. If you don't know Chef, you need to learn Chef. Everyone is using Chef in the commercial world right now to deploy applications. Right, that's job security. They also have a new service called Code Deploy. You deploy code to Code Deploy. Doesn't matter what type of language you're using. Amazon packages that up and pushes it out to servers. And you choose how it gets pushed out. It provides basically a blue-green scenario as to help the servers, and it provides zero downtime for your application. The other management pieces, so you probably, again, depending on your experience level, if you ever worked in a data center, you're probably using Cisco, HP, Dell. It's an alphabet soup of vendors within a data center. So having to inventory, standardize, and automate that data center is very difficult. Well, what Amazon has done is standardize that across all their regions, and in doing so, they can provide things that never existed before, like CloudTrail. So CloudTrail is essentially it can look at every single action that happens in your environment. If you provision storage, if you deploy a server, if you change the security group, anything from an API call, CloudTrail tracks. So if you want to know when things are changing in your environment, or you want to automate some sort of EC2 instance to launch based on a CloudTrail event, you can do that as well, right? You can automate your environment. And then identity access management so that your users can get in. All right. Anyone have any questions? I hate just talking and talking and talking. Anyone have any questions? Does everyone know all this stuff already? No? All right. So back to the business side, because I love the business side. So if you take a normal on-premise environment, traditional data center, you're looking at a small implementation about $260,000. That same data center on AWS, you're looking at 49% reduction in your cost out the gate, and that's probably conservative. You could probably even go lower. Amazon has never raised their pricing, except for Prime. That's the only time they raise their pricing. But on Amazon Web Services, they've never raised their pricing. And so as of, I think about a month ago, they lowered the cost of S3 and a few other services. So you're looking at about a 58% reduction in cost, and that's over a year. This guy had to pay this up front. This is paid over a period of time. And on top of that, if there's new infrastructure, new chipsets, new Amazon instances, new technology, you can take advantage of those immediately on Amazon. You have to wait for your on-premise stuff to go into warranty or expire, right, and then purchase, right? So there's a significant advantage from an infrastructure perspective moving to AWS. Now, you're going to say to me, that's great, but what if I spin thousands of instances? So I was telling the guys today that Amazon is death by $1 million cents, right? They charge you by the cent. So if you don't design your applications properly and your infrastructure properly, you could actually be more expensive than your on-premise, right? So one of the things about Amazon is right scale. You have to scale for what you need right now and the minimum amount you need right now, and let Amazon automation scale for you up and down based on actual demand. That's how you get these cost savings. If you just launch a bunch of instances and let them run, and you mirror what you put in your physical data center, in your Amazon data center, and you don't take advantage of any of the Amazon automation, you're probably going to spend the same or more, right? So it's not no advantage about using the Amazon cost reduction services. So, how many developers do I have in the group? Who considers themselves a developer? Most people. All right. How many people are engineers that actually are and network guys? All right. Before, everyone was very much still tied and isolated from each other. Application developers didn't need to know about security. They didn't need to know about networking. They didn't need to know about administration. However, now that you can script and automate and provision everything as part of one workflow, it is very important that you understand all those components. In fact, those components are going to be necessary as part of the DevOps model. I would encourage everyone to take a holistic view of application development as it relates to infrastructure, so that you can deploy these services. How many people have ever used Jenkins? All right, we got some Jenkins users for that. So Jenkins is used for everything these days. Right? If you want to automate a job, you use Jenkins. Essentially, that's what most of our commercial clients are using. How many people use GitHub? All right, good. That's good to see. All right. So Amazon has solutions, a very simple solution called CloudFormation. Based on JSON, it allows you to essentially script out and template all your resources that exist within your Amazon environment. And you can deploy those resources as many times as you want across accounts and automate this to a point where you can dispose of your infrastructure. You can literally deploy infrastructure, a very complex environment in 5 minutes, and terminate it 5 minutes later and relaunch it in another availability zone. And the way that most of my commercial clients are doing that is they deploy to Git. They do continuous integration with Jenkins, which automates the deployment of the CloudFormation templates. They target the environment that they want to deploy to, whatever region and availability zone, and poof, the environment's built. They use Chef, Ansible, other app automation tools to build those environments. And how many people SSH into their servers? RDP? A lot of Linux people. That's going away. Some of my larger commercial clients, we don't even open up SSH anymore. Why? Because we can automate the full deployment of the application, pull the logs from the servers, and see what's going on in real time. And there's no need for manual access to those servers. Right? That's a shift from an operations model. Big shift. So, cloud-friendly applications. So we talked, Amazon loves to make everyone believe that everything is cloud-friendly. It's not even close. Most of the applications are legacy applications. They've never been deployed in the cloud, and they need to be re-architected. So how do you do that? So you need to look at your Amazon architecture environment and take those legacy applications and map those to the Amazon services that are available and make those cloud friendly. They need to know about S3. They need to know about elastic block storage. They need to know about disposable infrastructure. Most applications, legacy applications, they need an IP address. They need to know their physical location. Their data is closely bound to the server. And in this world, we have to have the coupling your data and your compute so that you can dispose of your infrastructure and you don't lose your data. That's not common. And so there's a big push in the market right now for developers and infrastructure people to build cloud-friendly applications and transition those over to Amazon. All right. So case study 1. So I know this case study pretty well. I built it, so hopefully I know it. And this is the GenomeX case study. I started this business about, like I said, a year ago. And it was actually brought to me by Amazon. So Amazon had a client, Nationwide Children's Hospital in Columbus, Ohio, who built a very disruptive genomic analysis solution. Essentially what it does is it takes the whole genome, analyzes the raw data, and determines what variants cause disease for children, specifically this for Children's Hospital. So the next generation sequencing market for genomics is really interesting. 3 billion sequence reactions happen in this machine right here. It looks like a big refrigerator with a computer next to it. Right? That's for one patient. It's 1.2 terabytes of data for a whole genome. Right? It takes 40 hours in that machine right there to take the biology into a raw file. So imagine you have 1,000 patients. That's 26 trillion base pairs, 1,000 samples. The end result of that data compressed is about 100 gigs per patient. So if you have 1,000 patients wanting to perform analysis, that's a big data problem, right? You guys can do the math. 100 samples times 100 gigs. They take that data and that's used for diagnosis and clinical treatment and outcomes. So you have a child comes in, they have some rare genetic disorder, you don't know what's causing it, you have to guess. You go and send their DNA out for sequencing, it takes 40 hours. And then after that, the analysis has to be done. So this is the pipeline algorithm. I am not a bioinformatics person, so I can't tell you all of the steps within the analysis. But essentially, it's alignment, realignment, deduplication, recalibration, and genotyping. What it does is it takes all those A, G, T's, maps them to chromosome position, and determines if there's a deletion, translocation, where one of the pieces moves to another piece of chromosome, or if there is an insertion where there's not supposed to be, and that causes disease. This is the analysis of algorithms that make that happen, and the end result of that is a VCF, variant call file. There's going to be a quiz on this afterwards. All right, so the problem is it takes 2 days to get to the raw data. That big sequencer, that refrigerator, takes 2 days. It takes 2 weeks to run the analysis of that pipeline. I have 1,000 patients. 2 weeks. Can't do it, right? Or you can, you're just that patient that's the 1,000th patient, it's going to be waiting a long time, right? Now you can say, well, if I have a large data center, then I can do more than one at a time. Sure. So let's say you can do 4 at a time. Typically, when we run analysis, we run 16 nodes. Each node is 32 gigs, 32 cores, and 256 gigs of RAM per node. We run 16 of those, all at once, just to do this analysis. And it takes 2 weeks. It's a mini supercomputer, right? So that's what groups do. They purchase supercomputers. And what happens is, how many have ever tried at least time on a supercomputer? Anyone? It's very expensive, and it takes about a month to get access, right? And it's all leased time, right? So that's a problem. So how do we resolve that? So one of the challenges that was posed to us, there's a project called the 1,000 Genomes Project. It came out of NIST, and the 1,000 Genomes Project essentially took samples, genetic samples from 2,500 patients. They did 2 samples, exome, which is 3% of the whole genome, and then their whole genome. And they sequenced them. It took them 18 months to run the analysis, just the analysis, 18 months. They had 200 people working on the project. It cost them millions of dollars. So Amazon came to us, and Intel came to us and said, all right, can you do it faster? And we said we could do it in 7 days. So what we did is we deployed a solution on Amazon, big data solution that basically took 70 terabytes of data. We were launching about 1,000 instances a day around the US region, and we automated the analysis of that solution. And we were able to complete it in 7 days. The cost of which we got a grant for is about $30,000 compared to millions. And we did it in 7 days. Which is pretty good. So how do we do it? So we have traditional web browser. We have Amazon provides elastic, what we call elastic load balancing, is exactly what they did, load balancing. And then we had a portal where it's just a web portal that provided dashboards and allowed us to a GUI interface to start and launch analysis. We used Amazon's RDS, MySQL database, to basically store all the metadata information about what we were doing. And what happened is the data was stored in Amazon S3. Does anyone know what S3 is? Okay. So Amazon S3 is object level storage. It is online blob storage. I can put whatever I want on it. Media files, and I have unlimited storage. I never have to think, hey, I got a petabyte in there, am I going to run out of space? I never have to worry about that. The limitation is, I believe it's still 1 terabyte. The file cannot be larger than 1 terabyte. But I can put as many smaller files in there as I want. So all of the S3 genomic data, raw data, was stored in Amazon's S3. Luckily for us, NIST had already moved all of their raw genomic data to S3. So we did not have to port the data in. So that helped out quite a bit. But what we did do is we indexed the S3 location and we put it into our RDS by uploading an index file into the GenomeX portal. And what that did is it indexed everything and said, here's where all your data is, here's all your samples, and the type of sample. We then automated the launching of the infrastructure. So what happened is we had an individual push start, and we used Amazon SQS. And SQS, as I said before, is a queue service. So it queued up 5,000 requests into the queue. We then had an Amazon EC2 instance located in different parts of the US, different regions, and all that instance did was fight to pull requests off the queue. That's all it did, right? And what it did is when it read the request, it said, okay, this is a genomic analysis or an exome or whole genome. My data is located in S3 at this location. And because of the data, we had the listener smart enough to know how much infrastructure to launch based on the amount of data. We then used Amazon's AMI. AMI is an Amazon machine image, the template, where we had deployed our algorithms. So the algorithms were just sitting there in a template form based on whole genome or exome waiting to get launched. At this point, I still haven't paid anything, right? There's no cost because I haven't used the infrastructure. The listener says, okay, I'm ready to launch. It then launches EC2 instances around the world. And they crunch. And they go, and they go, and they go, and they go, until they finish, and they provide status updates back to my queue for updates, which my portal can read, and tells my users, oh, this is where we're at in our analysis. And then what happens is it says the result queue says it's done, and it takes the data off those instances and puts them into S3. And updates my database saying that there's new content in S3. And now I have performed my genomic analysis. So we did that essentially 5,000 times. And one of the things about our algorithm is that's very unique, is that it can parallelize over many compute nodes. Our other competitors have to go serial one chromosome at a time, which is part of the reason why they can't span across many nodes. In Amazon, however, can anyone tell me why I want to get through and launch as much infrastructure as possible and get to the analysis as fast as possible? Can anyone answer that question? Why does 1 hour differ from 2 hours, really, when I'm doing this, but it takes everyone 2 weeks? What is that? That would be a very nice thing to think about, but that's not what I'm thinking about. That's true. Money. This is all on-demand infrastructure. I do not pay for anything on this side until it launches. As soon as it launches, I pay for that first hour. When it goes past that first hour, I pay for the second hour. So on and so forth. So if I can get to that analysis in under an hour, I'm paying 16 instances. My cost is about $2 an instance. You guys can do the math. That's what, $32? Is that right? I can perform whole genome analysis on a 100 gig file for $32 in 2 hours or so. That's pretty amazing. I couldn't buy the infrastructure to do that in that fast, no way. And on top of that, I didn't have to worry about, do I have 1,000 servers? Now, we used 1,000 servers because we didn't want to mess up. If we thought that, for example, we could have used 2,000 across many regions, but if we had an error and those servers just ran, we're paying for those servers. So we came up with a good number of 1,000 and did that for 7 days and were able to get through the analysis. Any questions on this? Have you guys ever designed solutions like this? Does it make sense? This is the new wave of the future of application development. And again, I could be an infrastructure guy all day long. I could know about S3, I could know about QService, I could know about EC2, but really the application group needs to know how all of those things work together to reduce my costs, to speed up my time. And I built, how long do you think it would have taken your teams to build a platform like this, the software as a service, that you can upload unlimited data to and crunch analysis? How long do you think that would take you guys? Beginning to end, starting from 0 to end result. Anyone throw a number out? Year? 2 years? For a commercial viable product? 2 years? Anyone? No one? 5 years? 8 months. To a commercial viable product. At a fraction of what it would have cost the pharmaceutical companies to do the same thing. That means I can compete with those big groups because I don't have to put that investment in, right? I can deploy infrastructure, I can write code, I can dispose of it, relaunch it, and I have a worldwide solution. I didn't have to put up those data centers like the other guys did, right? That's how you guys compete in the future, or even now. So if you have applications, you need to really rethink how you're deploying them and the solutions behind them. Case study 2. So this is a federal solution case study. I won't go into the actual client, but this is an architecture that is currently being deployed for a large federal client. Now, the federal government is a completely different animal than the commercial world, right? You have compliance matters you have to deal with, federal regulations, security you have to deal with. One thing you're going to hear me say is FedRAMP. So one of the advantages of Amazon is it's FedRAMP compliant for a lot of the infrastructure services. That means that it's authorized to be used for the federal government. However, when you're building an enterprise solution for large clients, you're going to hear, oh, the government can't move to AWS. It's not secure. That's not true. It can be very secure. In some ways, it can be more secure than physical data centers. And the reason being is I can move my target around, right? So how many people have ever hacked the system before? Ethically, of course. Anyone? Okay, we have some ethical hackers. Okay. What is your number one point of attack? What are you looking for most of the time if you're going to do a simple hack?
What's exposed? Where are the doors?
Where are the doors and what's exposed? Finding IP addresses, going after ports, scanning, so forth, right? That's what you're looking for. So, if I can dispose of this environment in 1 day, 1 hour, in 5 minutes, and relaunch it somewhere else, the target is now moving, right? And so there are lots of organizations out there that are taking advantage of that model. Some good guys, some bad guys, right? That they are basically can be in US West today, US East tomorrow, changing their IPs, changing all kinds of stuff to basically protect themselves. Additionally, if you really embrace the DevOps model, which this organization is in the process of doing, they refresh their infrastructure constantly, and they pull back their golden AMIs, Amazon Machine Learning. Why? Well, If it has been attacked, and there's viruses on there, if every hour or 2 hours you get a fresh image, right, that is virus-free, you're now changing the paradigm of how security is done, right? Additionally, if you're familiar with operations, you're going to deploy SCCM, SCOM, update services that are going to look for all your servers and see what hasn't been patched, and it's going to go out and patch all those across your environment. We don't do that anymore. We update a machine image and let the environment refresh itself. That's a completely different model than what currently happens in normal data center operations. In this architecture specifically, probably running out of time. 5 o'clock? Okay. In this architecture, we are doing a hybrid. So we have physical data centers, and you're going to have customers that are not going to get away from physical data centers because they've already invested in them, and there might be some higher security levels you have to deal with. That come through trusted internet connection, which is essentially a security inspection tool, and then connects through VPNs to all your different AWS environments. And the life cycle is dev, they have the security management, and production release. And the beauty behind your dev environments is you deploy them, you test, and you terminate everything. So the cost of dev is not much, right? Because you don't have those environments up very long. From a production deployment, you can now follow a life cycle, right? That most organizations want to follow, but tend not to be cautious on for the environment. So, application deployment model in this scenario. Amazon has a service called Code Commit. It is Git. It's GitHub. But it's a managed service by Amazon. So, what our developers do is they connect to the network, they commit their code to Code Commit, and then they run CloudFormation, they run OpsWorks, they run all of their different tool sets that automate the application deployment to their virtual private cloud. Right? That's push button deployment. Lays down the whole network, lays down the applications. We then have a security person that goes in and runs Nessus scans. They run all kinds of vulnerability testing against this dev environment to validate that it's good. Once it's good, the target changes from dev to production and we release. That is all push button deployments. No manual intervention anymore. And this is not pie in the sky, this is actually currently being done by lots of organizations. Case study 3, disaster recovery. That looks like a mess, right? So, as I said before, disaster recovery is the first thing that usually gets cut from budgets. Not anymore. In fact, disaster recovery is the lowest hanging fruit for Amazon. You have a data center, an active physical data center for a customer of ours in New York. They experienced the hurricane, and they flooded, and they lost a lot. It took them a month to get back up, the data center back up operational, and they lost a lot of data. So what we're doing for them is we're porting all of their applications into a dev environment through vCenter. There's a connector that you can use to actually take your virtual servers in the physical data center and map them and deploy them as EC2 instances. We mimic the networking topology here, over here, and we test to make sure those applications work. And then we take snapshots, AMIs, of all of the validated solutions, and then we move those snapshots to an isolated production environment, and we don't turn them on. And they just sit there. It costs us about $30 a month. And now, what happens is, if this goes down, we turn that on in the cloud, and they're back up. When that comes back up, we turn that side down and turn on the cloud. We handle all the data replication pieces. So disaster recovery doesn't have to get cut anymore because you can quickly and efficiently, and this is not even a cloud-aware solution. We're taking exactly what they have, porting it over, and have it on standby. And because the servers are not on, we don't get charged. We get charged for storage. The storage is 0.0275 a gig per month, which is pretty inexpensive for an organization that has to spend $500,000 to $1 million on their large area network storage. Any questions on this? Because I want to leave some room for any questions. All right, it's your time. So, was this helpful? Is it too much? I wasn't sure what the level was or not. You guys have any questions for me?
Yeah, I do have a question about your cost model for the
Yes.
Seems like the strategy is to kind of take enough machines so that you use that amount of time that you spend actually processing on AWS is minimized. But would that always be the ideal strategy? Or, for example, the children's hospital, would there be some kind of model that you want to deploy a month before actually functioning data?
Great question, and the answer is yes. So we are looking at metrics over time, and there is a strategy that if you have enough analysis running through, why dispose of the infrastructure? Just leave it up and gain, you actually gain speed, right? Because as part of the analysis, that 2 hours, 15 to 20 minutes is actually launching the infrastructure and getting it ready for analysis. So we are actually looking at that exact model. And so we talk a lot about on-demand instances. So on-demand instances are essentially you pay by the hour, and they're more expensive by the hour. But if you have a solution that's very expandable, meaning that you need compute and goes like this, on-demand is great, right? You don't have to have them up all the time. However, there's a model called reserved instances. You pay up front, and then you pay a very small hourly cost over time. So what we're looking at is looking at how many servers are constantly on in a given month, purchasing reserved instances for that 50% of that amount, so that the next month those get utilized, and we save an additional 40 to about 50% on the overall cost when we do that. That model does exist. The other model that exists, Amazon has a spot instance market, so it's like a commodity market. You pay 25 cents 1 hour, and maybe pay $2 the next hour. It's all based on the community, right? The spot instance market is really interesting because essentially we can run one server at a time to do the analysis. It might take us 6 hours, 6 to 8 hours instead of the 2 hours. However, we can possibly launch 1,000 of those at a time and not spend as much. So if you have a large research project that they don't care that it takes 2 weeks to get done, that they just need the end data, using spot instances saves you another 70% of the cost. So it really depends on the workload, and we're looking at all of those. So that's a great question. Did I answer your question?
Yeah, there's quite a few cloud providers. Are they all proprietary? Or do you see them moving to a standard? Or we're going to be, the cloud providers going to be too big to fail?
So what I'm seeing happening is we're probably about 3 years out. Cloud is going to be a commodity. So I almost look at cloud computing as electricity, right? The utility, right? So I use it when I need it. Whatever utility is cheaper, I'm going to use. We're not there yet, but we're already integrating Microsoft Azure services, cloud services within AWS as well as Google. So what you're going to see is there's tools out there like Ansible, there's tools out there like Packer that actually allow you to script your infrastructure and you just determine the destination. It's Google, it's Amazon, and it deploys it for you without you having to worry about it, right? The reason I say it's not now is because there's a lot of services that are in Amazon that don't exist anywhere else, right? So trying to translate what Elastic Load Balancer is in Google or Azure, which don't have those services, is going to be problematic. But that's going away. Now storage is a commodity, and we're already looking at that. So we're looking at to see if Google's cheaper today, but Amazon's cheaper tomorrow or next month, moving the storage components around. Because by listener in that genomic analysis, it doesn't care where the storage is. It could be on-premise, it could be big chips. Right? And that's actually a good point. So why is, in this model, everything's decoupled, right? My portal is decoupled from my queues, from the database, from my storage, and from my analysis. The reason that's important is if tomorrow my storage is Google, all I do is tell the listener to point to Google, right? I don't disrupt the rest of my solution. Additionally, the queue service is based on permissions. So if I give somebody, like a customer that has a on-premise solution, access to send requests for genomic analysis to my queue service, they can run analysis and never touch my portal, right? We can decouple all this in anticipation of new services as well as new cloud vendors coming to market. Questions? You guys are being too easy on me.
Maybe just one more question.
Yeah.
No, not me.
One more question. Anyone? All right. Well, I appreciate it. Oh, you got one?
Yeah, and as well, I'm curious about how on the Amazon side of things, how they handle the distances. So imagine so once it gets to the queue stage, you don't have control of how much distance to
Yeah.
get available for this.
Sure.
So is that just
You mean the ones that are just sitting there waiting?
Yeah.
So they're essentially not even running. They're just templates, right? So as soon as I point to the template and launch it, that's when I get charged.
I guess I'm asking another piece. Like, if you wanted to say get this done within 7 days, at the time, and we're able to make a whole bunch of templates all at once, they probably wouldn't all be applied deployed at the same time, or in Amazon.
They don't care how many templates you deploy at the same time. Now, I always say, you know, Amazon's unlimited. There's capacity issues with them as well, right? So they do limit how much you can deploy per account. You can raise those limits, but that's how they do capacity. Yeah. All right. Well, thanks everyone. Appreciate your time.
If you haven't, grad cities, if you have